Thank you very much. Good morning, everybody.
Morning, Chris.
How's it going? I will start by apologizing because you guys are getting the after 2 nights in residence presentation. So we'll see how things go, how coherent they are. But I'm more than a little bit groggy this morning. So today I want to talk to you about assessment. From my point of view as a teacher, my overarching goal when I think about my lessons and my students is how can I improve how much my students are learning? And I'd like to start off by sharing a short excerpt of my students in action. I would like you to observe what they're doing. I would like you to listen to what they're saying. I think the volume will be loud enough. And then I'll be asking you some questions. So maybe if we can hit the light. All right, so now here is an excerpt of my students in action, and I'm going to ask you a few questions about it.
No, is it full gravity when the things are pushing out?
Oh yeah. So probably they give you the coefficient of friction. They give you the.
Fn should be this way. Because pressing against the wall, so Fn is this way. Like you're pressing it.
No, but your field lines should point out.
The black ones are negative.
Test particles are always positive.
No, but the black ones are negative.
But your test particles are.
And these are my questions for you. So what did you observe? What do you infer is taking place? Let's take just about 2 minutes. Turn to your neighbor, say hi, good morning, and your thoughts. Go for it. All right, so there's a lot of ideas being shared there. And this is my question for you. That's a very, very quick glimpse of what was going on. But, you know, if you have to make a wild guess, do you think learning is happening there? Let's take a look at that video again. And now I'm going to run the full thing.
No, is it full gravity when the things are pushing out?
Oh yeah. So probably they give you the coefficient of friction. They give you the.
Fn should be this way. Because pressing against the wall, so Fn is this way. Like you're pressing it.
No, but your field lines should point out.
The black ones are negative.
Test particles are always positive.
No, but the black ones are negative.
So this is our grade 12 physics exam. Starts off with 15 minutes of discussion. They're presented with the exam questions with the numbers removed. And this is exactly how they work in their day-to-day classes. This is exactly how they work on their unit tests. So we can take our traditional tools and techniques of assessment and we can add learning to, well, everything. And that really should be our responsibility, our main goal as teachers. We want them learning as much as possible all the time. So you have no doubt been instructed by the ministry, the school board, the different varieties of assessment as learning. What I really believe is that assessment is learning for a couple of important reasons that I want to share with you as we go through this workshop today. So, first of all, assessment can be thought of as feedback. Valuable information that will help the students improve. And we have 2 important questions to ask ourselves. What types of tasks, in a very broad sense, should we try to assess? And how do we assess those tasks? So I'm going to be sharing with you my approaches to answering these questions. And it starts off, I want to start off by mentioning a bit about how our brain works and learns. So if you think of the different mental processes that our brains go through, it can be broken down into 4 parts. Now, the actual parts of the brain here, we don't need to worry about. What's important is what goes on in these parts. So, in this back region of the brain, we receive and start to process the input from our senses, or from the brain itself. in this part of the brain, so lower to the side here, our brain assigns meaning to these inputs, to these signals. And then it sends the messages to the front part of our brain, the prefrontal cortex. This is where we do our higher order thinking, our abstract thinking, for example, putting together plans. And then signals are sent to this part of the brain, the top part up here, that's our motor cortex, and that's where we figure out what actions our bodies will carry out. And taken as a whole, this is a cycle which repeats in our minds, and we refer to it as the cognitive learning cycle. So those of you who were in my presentation yesterday, you had a sneak peek of this. So as far as we can tell from a scientific perspective, this is the way that our brains are designed to work and designed to think and learn. So as educators, it's really important for us to understand that and to figure out how do we best harness this natural learning cycle that our brains are built with. And if we think about traditional learning, the traditional class provides a lot of input for students. If the students are busy taking down notes for most of the time, this is where a lot of their energy is spent. And they are given very, very little time to make meaningful connections between the ideas being presented and their personal life experiences, or the prior knowledge that they may have learned in your course or other courses. So we, on the whole, are not helping our students move through this critical part of the learning process. And the search for meaning is a core part of science. The natural world is fantastically complex. When they look at it, they see something totally different than when we look at the natural world, the universe. They see all sorts of stuff, but they don't know what the patterns or the ideas are. And so this search for meaning is crucial for their learning process. And we have to allow them many opportunities to do that. You see anything yet? You know the trick, the stereograms? Yeah. Across your eyes. And I had to stop doing this at a certain point after I was preparing my presentation. Butterfly? Yeah, takes a little bit of time. So, we're not helping our students with this part of the natural learning processes that their brains follow. Now, another very common part of traditional instruction is that it involves a lot of manipulation of information. Right? You're taking what's in the textbook and you're reproducing it on your page, maybe in chart form or something, but you're just manipulating information. Or, especially in physics classes, you're doing a lot of math. And that all takes place here in the prefrontal cortex. And it can happen with very, very little meaning informing it. And it often happens with very little meaningful testing of the results. Our brains want to go through this process. But how often do we provide those student brains with meaningful, this is the feedback part, and this is where the assessment is linking into this. How often do we provide them with a meaningful way of testing their understanding? That growing understanding at many, many points along the way through their learning process. I know when I was teaching 15 years ago, right, the only opportunities the students would have was you check the answer in the back of the textbook, or that quiz which is coming next week, the test which is in 2 weeks. That's not nearly enough feedback for them to successfully learn. And so we need to provide them with as many opportunities as possible to make meaningful tests. And how do we define meaningful? Well, how do scientists get meaningful feedback for their work when they are exploring a new idea? Just take 1 minute with your neighbors. Share notes. So how do scientists do this? Well, what are some of your ideas? Theo?
Run a controlled experiment.
They run an experiment. Margarita?
They go to the peer review, right? of
The peer review process?
Yes, and the reviewers would suggest them new experiments or maybe they didn't have enough samples, not enough data. Maybe they missed some ways to test.
Great, thank you. It's Roberta.
They talk with their colleagues over coffee. Like, that's the problem. What do you think?
Yes, informal conversation. Anybody else? Yes.
Thought experiment. Would it work in this circumstance? Let me run the math. If you're a theorist, does it work?
Thought experiment, Gary.
And compare it with what they've already learned from the past and see if it fits in and how does it fit in.
Try to compare it with known models. Okay, great, great. So I'm going to share with you another video of what I do in my class to help students test their understanding. Okay.
Yeah.
Look at that. Look at that.
Good. Yeah, that means precise calculation.
Good job. Good job. And what's your prediction?
Like 4.8. Is it 4.6?
Parallel into parallel. What is it?
4.8.
So does that agree with your prediction?
Yeah, we got 4.9.
We got 4.9. So yeah.
And what was your uncertainty?
Like, plus or minus 0.1.
So do they agree?
Yeah, so yeah.
Good, good.
You want to stop it?
Why is it so? They are all constant.
So it keeps measuring the size of the normal force.
But we're still at 3.
So the tension force is at 3. And what about the normal force?
Around 2.
It jiggles a little bit, but does that agree with your prediction? Go ahead.
Oh my god, it's literally like right underneath.
Whoa. Okay, go. Oh, that hurts.
It died.
Oh, that's pretty. 1 centimeter.
It's so sick.
Yay!
So that when you're testing normal force, was that like a probe that they were pushing down on, and that was giving the data on the screen?
It's a force probe.
Right.
And I just put a plate on top of it.
So instead of doing a pull, it's a push. Got it.
So as much as possible, I try to provide very regular opportunities for my students to do very short testing experiments. Right? You make a prediction, you go see, does it actually work? And they do that very regularly, and that helps them to refine their understanding. That is critical feedback for them in the learning process. So I consider that a very important type of assessment. So going back into the cognitive learning cycle, we can, that example is really focusing on this testing phase here. That's what's going to help them to refine their knowledge and understanding. Now, I want to contrast or maybe frame our conversation by thinking about a different type of education, apprenticeship. If you are learning a trade or a craft, you may have learned something like this in the past. So you would go to maybe a master cobbler, and you would start to learn the process of cobbling. And I know that none of you are probably cobblers, but for a moment, just imagine you're a cobbler, and what would the first few tasks be that you would assign to the apprentice? What do you think?
Put the nails.
Right, everything's done. There's just a couple nails to tap in.
Yeah.
Good?
Scissors.
Take the old shoes apart so that you see how they're put together, right? So if you need to
You
repair
have to
something,
fix the
take
shoe.
it apart first and then hand it to the master to put it back together.
Take it apart. Thank you.
Just from the experience working in wood shops and stuff, like they always just tell you to work with the tools first. So like you just get set sharpening stuff. So just like tool maintenance, you get familiar with the tools.
Great. Thank you. Yes.
Cutting shapes with the scissors very precisely, because the saw has to be identical, right?
Great.
It's magical.
Great. Anything else?
Maybe get them just to try right from the beginning, try to make one on their own, and see the challenge behind it.
Acquaint them with the challenges ahead. Okay, great, great. And if you were the apprentice, how would you know if you were on the right track in this kind of environment? How are you getting your feedback? What do you think? It wasn't necessarily a glamorous role.
If he gives him more hours, gradually.
Get some more hours. Roberta?
Well, there is a product in front of you, and you're looking at how good that product is, which match more what their students were doing. They made a prediction. How well does it match that?
There's a useful product. Theo?
You get handed more complex tasks.
Make shoes for yourself and try them. Right?
So often the apprentice knows pretty quickly whether or not they're on the right track, because there's a real tangible thing that they're putting together, and they can judge whether or not it's serving its role or function, or they have the master nearby to compare with, or the work of their peers. So this is the feedback cycle for a traditional apprenticeship role. Now, let's imagine for a moment you're a university professor, right? Same field, and you have to teach a course about shoe construction. What do you think that first class would be called? So if you had to make up your first lesson, Shoes 101.
The history of shoe construction.
It would be almost guaranteed. History of shoe construction. Lesson number 2 might be
Functions.
the functions of the shoe.
No,
Great.
the mathematical functions. Mathematical functions.
The mathematical functions for the shoes. Yeah, and an exhaustive study of the different kinds of shoes, right? This is surely how it would be presented. And if we think about the person in, did that not appear? No. If you think about the person in this class, right, how would they be getting their feedback on the skills that they're trying to learn? It'd be like the midterm, when all of a sudden, right, you have all the shoe parts there and say, okay, you got to make a shoe. So I'm not trying to make fun of university professors, but I just want a clear.
You can be a girl maker.
But I want to try to exaggerate these differences as much as possible. So if we think about the role of apprenticeship, right, that apprentice is learning a process, shoe making or shoe repair. And this is a combination of knowledge and skills. So, as you guys have described, right, this complex task will be broken down into a lot of smaller tasks. And the relevance of each of those individual tasks is almost always obvious to the apprentice. Right? You know why you're doing this. And you're constantly getting feedback, either from your peers or from the master cobbler. Now, let's think about what we are trying to do. Right? We are putting our students through a cognitive apprenticeship. Often, there are no physical, tangible things to be constructed. We are constructing knowledge and ideas. Learning science. We want our students to learn a process. Right? Science is a process for the construction and testing of knowledge. And it combines knowledge and skills. Now, in traditional education, we emphasize this greatly, and this often gets left behind. And so students have a very incomplete understanding of what science is, and a very weak set of skills that are necessary to be a productive scientist. So as teachers, what we want to do is simulate the workshop of the scientist in our classroom as much as possible, and create those subtasks that students understand and can test and practice their skills on. So, without a tangible product, right, we have to make our thinking visible, and we have to train our students in the thinking processes that scientists make use of. So we need to start with the big picture, and then help them understand how the subtasks that we are about to help them learn connect with that big picture. And provide them with as many opportunities as possible to get feedback on their growing skills. And an important thing that I've been changing about my teaching practice is the role of self-assessment. So self-assessment is a very important skill to develop. Why is that? Well, let's take a look at another peek into my classroom here, where I'm having my students practice these skills. I am going to assign each group a part of the homework question. I'd like you to write it up very carefully on the whiteboards, and then I'll explain what we're doing next. We're going to place the whiteboards along the sides of the classroom, the windows or the chalkboard. And I would like you to place a different colored marker right in front and right beside your whiteboard. Each person will have their homework in their hand and start to do the whiteboard. And when you look at the work on the whiteboard, if there's something that either you're not sure about or you think might need to be corrected or improved on, then you can just circle that on the whiteboard. Ladies and gentlemen, have a seat, please. And let's talk about our whiteboard work. One of the challenges of our volleyball question is that you have to choose the events yourself. So this group has chosen the event. In a moment, I'll ask you to reveal what's on your whiteboards, and then, without moving around the room, have a look around at every group's interaction diagrams and decide if there's anything that you need to improve about your own work. Okay, so please flip the boards, have a seat, look around, and decide on improvements. The interaction diagrams that I'm seeing around the room are very high quality. I'm very impressed with what you've done. So I've often wondered over the years, why aren't my students improving? And I came to realize that they spend very, very little time thinking critically about their own work. And so I need to provide opportunities, structured opportunities for them to do this. And so these were two examples of that. And very often, on their own, comparing work with their peers, they can come up with the right answers to many of these questions. And then my role is just pointing out a few fine details at the end. But I'm trying to get them to do as much of that critical thinking as possible. So this is one example of how I've been incorporating more self-assessment into my classroom. Do you have any questions about what we saw there? Okay.
Do you read their comments? Do you read their comments about themselves?
What they've written on the whiteboards? Yes, I go around, I look at the whiteboards, I see what the common issues might be, and I use that as the content for the discussion that I lead. Roberto.
I was just wondering, within the class, do you see that there's a set of students that tend to be basically taking your role and criticizing the work, and another set that is more listening to that? Or how deeply do you find your self-assessment? So do they all get involved in making the critical stuff?
It happens at different levels with different students. Some students are just trying to keep up, and so they're completing pieces of their homework by looking at what their neighbors have done. Others are taking a very critical eye, are getting involved in those discussions. So it's happening at each of their levels at the same time. Yes, ma'am?
Are you grading the students on this?
No, no. So this is a very important form of assessment, but there's nothing that's recorded about this process. It's just for their learning purposes. Yeah?
I teach in a ministry inspected school, so the ministry would want us to actually take pictures, for example, of the whiteboard, so as evidence of assessment as learning and for.
We're supposedly supposed to be documenting all sorts of interactions that we have with our students. Another thing that we do is we use skill rubrics. So this is an idea that I got from Eugenia Akina. She's an American physics education researcher, and it's another attempt on my part to try to help students look at their own work with a more critical eye. Because once again, I was always frustrated. Like they're drawing these craptacular force diagrams over and over again. It doesn't matter how many times I stand up in front of them and I say, right, you have to remember to do this, you have to remember to do that. But they keep doing the same things, the same mistakes all this time. Well, now they have a clear rubric which shows the exemplar, it shows what makes for a high-quality force diagram, interaction diagram, all these technical physics diagrams that we're training them to develop their skills in. And they can do this work of self-assessment. So we'll be going through a lesson, we hit that important force diagram, and I'll say, okay, turn to this page in your handbook, write the rubric for the force diagram, and now I want you to write down a number. So evaluate it. And then I'll come around and take a look at what number you've written in your evaluation. So I can see the work that they did. Oh, and sorry, I will often ask them to, in a different colored pen or pencil, mark in any improvements based on looking at the rubric. So then when I come around and I take a look at their work, I can see what they originally did, what they've changed, and their assessment of it at that time. So I get an important glimpse of their thought process and their skill development. And they're, again, regularly thinking critically about the quality of their work. So this is a common feature in my classroom. Now, the other important reason for developing the skill of self-assessment is because of, well, this psychological research, which we are all familiar with, even if you've never read their paper. Because there's this amazing, the title of this paper really says it all. And I'm sure you've never met individuals who possess this characteristic because, you know, but unless you regularly reflect on your own skills and behaviors and attitudes, you are less likely to improve them. And so this helps to counteract this effect. We also make use of self-assessment when it comes to quiz time. So our regular quizzes involve, so you do the quiz, then you bring it up to the front when they're done, and then in a different colored pen, they will look at my solutions for the quiz, and then they will mark up their work. They'll mark up any corrections or improvements, and then hand that in. So I have a brief article that I've written on that, as well as a sample of these quizzes on the back.
That's really cool. That shows that you personally value improvement and correcting.
I say the word improvement an awful lot in my classroom because that is the key thing that I want to happen. It doesn't matter where you're starting from, there's always that room to improve. And there's always positive steps that our students can take. So, let me explain a little bit about the quiz itself, and that might answer the question which is coming here. So here is a sample quiz. So you have the black and white version. So this is the colored version. So the kid wrote in pencil. They used blue pen to mark down any corrections or improvements. And I'm able to see both. I can see their original work and the improved work. And to show that I'm serious about it, I give them a couple marks for the quality of their improvement self-evaluation process. That they look thoughtfully or carefully at my work did they make the appropriate changes to their work? And the student didn't do such a good job at that. So this is a skill that that student really needs to improve. I can see that they are not seeing what's the difference between my work and theirs. Right? So that they're not cluing into some of these basic ideas. They're not recognizing it as different or needing to be improved. So there's a lot of information that I can get about the student's state of skill development and their mental awareness of what are the valuable aspects of the work and what are the sort of side details. So this process gives our students lots of feedback, and it gives me much more insight into my students' thinking process. And it solves a long-standing problem of mine, right? You put all that time and effort into the descriptive feedback on their work, and you know they're not looking at it. You know they're not using it to make an improvement. And you're wondering, why am I doing this? I know I have to justify their marks, so I have to at least write something. But it's not part of a meaningful cycle of learning. And so here, they are making those improvements, so they are much more likely to be aware of them, remember them, make use of them in the future. And so this is helping them to raise more awareness of their own thinking process and where they are in their own learning cycle, their development of skills. Now, just going back to this quiz, I often have a metacognition question on the quizzes or tests, asking them to think about their learning process. And this particular one, I asked, well, how accurately do you think you completed the 4 parts? And the kid says, I think I got it all right. And you can see the results here. So there's a real mental disconnect. And so we have to help those students make that connection to recognize that, yeah, there's actually a lot of room for me to improve in order to start that improvement process. Because otherwise they're simply not aware of it. So why would they put in time and effort to try to improve?
Just checking. The student wrote that after looking at your solution.
Sorry, that's part of their seat work.
Okay.
They do that before they hand it in.
Okay, phew.
Yeah.
Okay, right, so that before. Got it.
Would you expect them to correct their metacognition?
That'd be okay. They could have a comment right afterwards. Obviously, I didn't.
Yeah.
Some of them do. Some of them do add on to that metacognition. That would have been nice if that happened here.
So before you do something like this with your class, where they have to go up and assess themselves, do you have, let's say, the first or second quiz of the year, where you go through what a process would look like in terms of reflecting? Like, do you do an example of what a work would look like, how you would mark it so they understand how to be critical of themselves?
There's a lot of that built into our daily lessons.
Okay.
So they've been thinking along those lines. And this is the very first quiz of grade 11 physics.
Okay.
So it's their first round through that process. And we also make use of these multiple choice answer cards, like the good old analog clickers. Right? The batteries never die. There's never a problem networking with the system. Right? It's fantastic. And I will ask them a lot of metacognition type questions, or questions that are trying to prompt them to think about their learning process. Sometimes, if it's a bonkers class, I will have this up an awful lot. Because they're not going to improve if they are not aware that there is something that should be improved. And so this helps to remind them that this is important for me. I'm hoping it will be important for you. And it's getting it into their brains. And they're very honest when they answer these types of questions. They know. Another kind of question, again, I use this with more bonkers class. How well focused were you on the topic today? Because they're probably not monitoring that. They're not thinking, oh yeah, I was on my phone half the class. So you have to make them aware, or else there's no chance for improvement. And sometimes I'm asking them about the learning itself. So I'm really hoping that by the end of that particular class, that new idea they're feeling pretty good with. And the measurement for that, as far as I'm concerned, is can you explain it to a neighbor? And so this is getting them to decide, okay, how did I do today? And it's prompting them to think about what to do next if they're not feeling as confident as I would like them to. So we're providing a lot of different types of assessments as feedback for the learning process. Now, there's another role that assessment can play, and that is as a reward for the learning process. And because this is a very dominant role of assessment, it's probably the primary one in many people's minds, often using the word evaluation now, it really sets the rules for the learning game. Right? We know the kids, many of the kids they're out for the marks. Right? They want to figure out how to get those marks. If this isn't worth marks, I'm not doing it. So the way that we set up our system of rewards determines what types of behaviors our students will employ in our class. And so we need to be conscious of this and then rig the system. Right? We want to rig the system to encourage students to employ the behaviors that we want them to develop. And our goal of cognitive apprenticeship, science is all about process. Knowledge is important, individual skills are important, but how they work together, that process of generating and testing knowledge, this is what the game is all about. And so we want to reward them for process. Did I go backwards? Yes, I did. So if rewards are only for final product, a final answer, then they know that. And they will obsess about that final answer. And it will short circuit a lot of the good process that we want our students to go through. So here's an example of that. This is a standard kind of physics question. And so inclined plane, pulleys, we want this to reach 1 meter per second at the top. And in the past, my students would have scribbled a few lines on a sheet of paper, be almost unintelligible, and they would present you with a final answer. And I would reward them for that, because they got the final answer. All right. But now I don't reward that behavior at all. I want them to go through a very carefully constructed process that causes them to practice the different skills that an expert, in this case problem solver, has. So in this highly structured process, they begin by constructing a pictorial representation, and there's lots of little details that I want them to pay attention to. Those are all listed at the top, so they're not worried about trying to remember them. But this is the first thing that happens in an expert's brain when you're presented with a problem. They're constructing a picture. What are the important pieces of information? And then they move on to...
Frustrated the hell out of the top level kids who just want to do the math.
Yeah. So in some of my former tests, I would have just pieces of these. So for one question, you might be doing the physics representations. For another question, you might be doing the word representation. And they were familiar with these from class, so they saw, I know what to do there, good. But the important idea here is that all of these steps are what experts do instinctively, after years of training. These are highly fluent and almost invisible skills. And we often forget to unpack them as experts. We are often not consciously aware that they are operating within our own brains. And so it's really important to have a very carefully worked out process so our students have an opportunity to apprentice at each of those skills. And so here we get to the math work on the back page. But that's not the end of it, because there's a final step where I want them to think about that result. Does it make sense? A quick check at the end. And so we have to reward all of these steps. We want to reward this process. Scientists get feedback from their discussions with their colleagues. So when my students are learning about Newton's third law, I give them a lot of discussion-based questions. Now, Isaac says this. Do you agree or disagree with Isaac? Right? Explain. This is exactly what the scientist would be going through, except it's a very simplified situation, suitable for their cognitive level. So again, we're giving them a structured environment to practice the habits and the behaviors that experts have.
Chris?
Yes?
This is absolutely what you need, say, for 95% of students. I'm just wondering, with the 5% who actually are already functioning as experts, not just, so do you modify this for the, or do you just explain why it's really important that they also go through the process?
Yes.
I'm not talking about somebody, somebody who can explain it. So how do you do that? Because we will have those students.
Yeah, it's part of the training process that my students go through at the beginning of the course. Something that I'm regularly reminding them about. That these skills, the effective communication of technical ideas, it's really important for experts to develop. You have to be able to communicate your ideas to a lay person. You have to be able to communicate your ideas to a team member down the hall who is not familiar with your work. And very often, those high-performing students really flounder when you ask them, okay, well, how did you get that? How did you make those decisions? They need to practice those skills in a conscious way, in a very focused way. So it's very valuable for them. And I also encourage those students to take a teaching role within their groups. Because they might find that they get the answers to the questions fairly quickly. So it's their responsibility to take the time to help out their neighbors with their understanding. And I try to encourage them that this is a valuable skill, the skill of teaching, and it will assist you in improving your own understanding. So I attack that from a number of points of view. All right, and then we get to the group work test, which we started today's presentation with in the form of our final exam. So the idea behind our group work test is we're giving students the test question. The equations are there. I don't focus on memorizing equations. I want them to demonstrate understanding and fluency of skills. And I give them the description and maybe a picture for the problem. Now, shortly after, start off at this end here, take one, pass it along. Pass those along. So they have 10 or 15 minutes to discuss the questions. So this is from a test about 2 years ago. You guys need one? I have a couple for. Great, thanks.
I get all. You get them all.
So 10 or 15 minutes to discuss. This is the exact question that will appear on the test, and the numbers are removed. Sometimes the actual question statement, what you're trying to solve for, what you're trying to accomplish, sometimes that's not there, sometimes it is there. Sometimes it's written in a veiled way in order to encourage them to focus on the ideas. And so this is a typical physics test. And so after 10 or 15 minutes of discussion, working away in their groups, they will adjust their seating to then work individually. I'll give them the full test paper, and you can see that's the exact same question. The numbers are there. Sometimes a few of the wordings are clarified, and then they're good to go. Now they can demonstrate their skills in understanding. So, how does this process of having this group discussion phase, how does this help our students? I'd like you to take 1 minute and chat with your neighbors. Let's go. So I'd like to hear your thoughts. How does this help our students?
I think it would help with test anxiety. So I found that's been a real issue with a lot of my students the last little bit, and I think this process of just like, okay, I actually have 10 minutes to think while I can bounce ideas off other people before I actually start on my own. I think that might help a lot of high-stress students.
Thank you. Alistair?
Add on to that, we had a really good point here that it gives you a chance to avoid the stupid little mistakes that,
Mhm.
that can cost you a lot more later. Right?
Yeah, thank you.
And that the simple concepts that we learn in class that look boring actually is very important in real life, right? Like the motion on the ramp.
Thank you. Roberta?
You've provided a very realistic situation where there's a lot of information, most of which may not be needed. And if somebody is doing this just on their own, they go, I have no idea what this is about.
Yeah.
Within the group can work together. Yeah, you're right. Yeah, there is too much information. Okay, well, what is the information we need? Because if you did do that group thing first, those students would get 0. Right? So they're going to get that first bit.
Absolutely. Lisa?
I just want to say in my opinion, in order for this to be very valuable, and it is, they need to go through all that prepping process to know how to do well in a group, because if they don't have that experience, and then they're put in groups and given this, even in those 10 minutes, they will be all under stress. So they really need to know how to do this.
Yeah, they can't meet this cold,
Yes.
so to speak. Matthew?
I just have a logistical question. We have a lot of problem with students avoiding evaluations, like missing them. You have, like, do they miss the opportunity to have a group discussion if that's the case, or do you have any issues with that?
If I'm able to get 2 or 3 of them together who have missed the test for whatever reason, I will give them that 10-minute discussion time. And so we go through that full process with them. If it's just one kid away, I'll let them ask me questions after reading it over for 5 to 10 minutes.
I think too, it kind of shows what you value as important by doing this, because you're allowing them 10 minutes to just think about, like, you're not valuing, okay, right to calculations and math, you're valuing thinking about the problem and what's important and what's not important.
So what are we rewarding here? We're rewarding collaboration, a focus on the concepts, on the ideas.
There's some realism here too, because you're exposing them to what the failure analysis crew for this particular thing probably did at first, right? They looked at the general situation without knowing any of the numbers to figure out what numbers they needed to figure out what went wrong, right? So you start with just the general problem, then you determine what you need to know, and then you can go looking for that, rather than gathering a whole bunch of useless information.
Thanks. Gary?
This is more akin to how real science is done. People collaborating, working with each other, sharing, bouncing off ideas, not just one person sitting by themselves.
Remember, our goal is to recreate the scientific workshop in our classrooms. This is how scientists behave. This is how engineers behave. When you're starting a major project or task, you're not going to do months and months of work before talking to a single person in your field. Figure out what's going on out there. Am I on the right track? You collaborate, especially at the beginning of that process.
One more.
Yes.
That when you have a complex problem like this, you first need to collect as much information as possible before starting to do the calculations. Right? All these numbers, what do they mean? Do we need more information? And as you get along, you may also need more information.
Yeah. Am I letting my students cheat?
Mention what you call cheating.
we construct the rules of the educational game, and we can change them at our whim in order to promote what we think is important in the learning process. A student who genuinely does not understand the physics concepts will listen to all those discussions in the first 10 or 15 minutes and will not be able to demonstrate the skills. They're not getting a free pass by listening to the other students. I've seen the weaker students who don't have the understanding. I've seen them write down the things their neighbors say, and they don't know how to take that information and put it on their own page. So it's not a free ride for anybody. You still have to know the stuff. But as Roberta mentioned, for those kids whose skills are still at a lower level, this type of discussion gives them that opportunity to find the start into the problem. And because there's such a structured solution process, just like I showed you with the ramp question, the roller coaster question, right? There's many opportunities for them to demonstrate their skills and understanding. So it provides an important support for the weaker student, but it doesn't provide a free ride. So, this process also emphasizes what I want students to focus on. Okay, where on Bloom's taxonomy are students operating during this test? Okay, they have to have the knowledge and the skills, but they're working up here. This is my goal for them, and so I prioritize that in the learning environments that I structure. And I've had students tell me that, oh, I really enjoyed that test. I learned a lot from it. Because I give them realistic problems. Here's some of my students. I told them that I'm going to be sharing this with some other teachers. Is there any feedback that you'd like to give the teachers about what we do in our class or our group work test format? And they said, yeah, it helps them to combat test anxiety. And they point out that if you don't understand it, right, it's not going to help. You have to do your work and your preparation. In this group here, they really like the fact that you're not alone. Right? In the real world, right, how often are scientists and engineers working alone? It's never. And they recognize that their tests are becoming a learning experience. So we can change the reward system in these educational environments that we construct in order to emphasize what we think is really important as teachers. Now, the last part of the evolution of testing, I've been changing how I teach for almost 10 years now. And changing the testing process is one of the last things that I've been adjusting. And this part is the newest. We've only been trying for this current school year. And I'll just go briefly through this because we're getting near the end of our time. So we've gone from a focus on a lot of content to a focus on skills. I don't worry at all about trying to cover the unit. You'll notice that this question here, it uses a lot of energy momentum ideas, but there's no two-dimensional momentum question there. It's okay. You have to do that in the class. And I want to focus on, I have to choose something to focus on. This semester's test was a two-dimensional momentum problem with energy involved in it. So you have to choose something and just go for it. Don't worry about trying to cover everything. That's not the purpose of the test. It's to check their skills. And so we've gone from many short questions to one or two longer, more nuanced questions. With our grade 11s, we go through a similar style of testing. The questions are shorter, simpler, more clear, less detailed background information, but we're starting them on that process. And we're moving away from a superficial survey of that content to focusing on deep understanding. Now, the one part that was missing from this revised test format was improvement. Right? How does improvement connect with this? And right, there was no motivation for students to improve on a test result. Well, I had to change that. And so what I've done now is I've broken up the marking system of the test into a series of skills. So for Force's test, there's 3 skills that I'm looking for. A communication skill, an ability to use our technical diagrams, force diagrams, and so on. And can you solve problems with angles using Newton's second law? Can you solve problems with forces in circular motion? These are the things that I'm looking for, and you'll be allocated marks based on how well you demonstrate these skills. You're not being allocated marks per question. It's per skill. Here I have an example of this mark breakdown for the momentum and energy unit. And again, in the students' minds, I'm trying to change the focus of... Oh, one more? Maybe one more. In this reward system, I'm trying to change their focus. It's not just on getting marks per question. It's on demonstrating understanding and mastery of certain groups of knowledge and sets of skills. And to incentivize the improvement process, students have an opportunity to upgrade their marks. So for example, on the one that I have on the screen here, let's see, is my next picture better? I should use that. So each of the skills in this assessment process can be reassessed. The students have to demonstrate to me in some concrete way that they've put in a genuine, meaningful effort to improve. So I look for evidence of that. And then we arrange a time. They come in at lunch, say, okay, I need to work on my communication skill and Newton's second law with angles. Okay, no problem. Take that out, give it to them. So the one that I handed out here for you folks is from our energy and momentum unit. So this skill reassessment focuses on communication and the second momentum and energy skill. And it's a challenging question. It's similar in level or difficulty to the original test. We're not trying to allow them to find an easy path, but it's meant to reward that effort that they put in to improve. And so, let's see. So as part of the evidence that I look for, every time I return a test, I return another version of that test, which is the test improvement page. So there's some instructions on what to do. So they go through their original test, and in each part of that test, there's a place where they need to describe their original thinking at the time of the test, and the changes or improvements they need to make to their work. Then they demonstrate that for me, and this is the first step in providing me with evidence that you are ready to have your skill reassessed. And then they'll do some extra practice problems or come in at lunch to get help from me. And when I think they're ready, and I ask them, do you feel that you're ready to do better? And if not, take some more time, get some more practice. But I want you to be confident that when you try, you think you've got a pretty good shot at improving, at getting a better result. And so the students write the reassessment. So I've given you an example of that. The students will mark it up with blue pen, just like they do with our quizzes. That keeps it a little easier for me in the marking process. And then I give them, have that here? Yep. So, okay, so you got an 8 and an 8 for both of those skills. So then we go back to their original test. Say, okay, you improved from a 4 to an 8. Right? That was a solid result. Here, that one stayed the same. That's okay. But they went from a 28 out of 40 to a 32 out of 40. They were rewarded for investing the time and energy to improve. So this is the last change, the most recent change that we've made to our assessment and evaluation process. So we're still trying to get a good feel for how to make this work, how to properly encourage the right behaviors. Because there are a few kids who say, oh, I'm not going to bother studying for the test because I'll just do the reassessments later on. But we make them jump through hoops to earn the right to have their skills reassessed. And they realize, oh, the problems are no easier. So, preparing well for the test and having your groups to help you, that's a major bonus. So we're trying to get the right set of behaviors going. This is a work in progress. Now, just to quickly wrap up, and then we can have some time at the end for questions. In traditional assessment, we tend to emphasize these things, a lot of content knowledge. And it tends to produce these kinds of behaviors. They're only interested in what will appear on the test or the exam. They take a memorization approach to it. Okay? They know, okay, I can stay up the night before because they just have to memorize stuff. And so many students have been successful with that strategy in high school. But I'm hoping that this process has a very different emphasis on skills, process, collaboration, understanding, and reassessment. And the behaviors that I'm hoping it to encourage are these. And I think they are happening. The students focus on learning the ideas in a deep way because they know the test question is not going to be a plug and chug. So I strongly encourage you folks to take a look at these resources here. This is a fantastic compilation of the science and the psychology of learning. It's free online from the National Research Foundation, American group. So just Google How People Learn. Download it. Excellent, excellent. And then this is a book which is written for really the post-secondary crowd, but it breaks down a lot of the psychological ideas in clear and easy to understand ways. I think it's still very useful for secondary teachers. So yeah, you can grab a photo of that. You can also download my whole PowerPoint presentation from my website if you want to go back and take a look at anything or grab some of the references that I showed. So we've talked about these two ideas today, and I hope I've given you a good sense of how I approach that with my own class. Because I really believe that assessment is learning, and that by changing the way that we assess, we can encourage the most productive learning behaviors in our classroom, and we can really help our students to learn more than they thought possible. So thank you very much, everybody.